All right, but looking at example 4, the first thing we want to do is pick two equations to eliminate one of our variables. But number 4 is a little bit interesting because if you note, kind of like if you look at this equation here, see how it already has one of your variables missing? Like it only has an x and a y term. Like, remember, like our first two steps is we're going to basically be getting rid of one of our variables so we can get a two variable equation, but we already have one here. So what we're going to do is for our step 1, like what you would probably want to do in this question is look at the first and third equation. Remember, I call this equation 1, this equation 2, this one equation 3. So if we write those two equations, and be careful when you copy the equations, like one of the easiest things to screw up on these problems is to copy them down wrong, which causes you to like get the wrong answer. So just be careful when you're copying these down. But since equation 2 already only has an x and a y, I want to see if I can use equations 1 and 3 to create an equation that only has x's and y's as well. So for my first step, I want to see if I can get rid of my z's using elimination. So it's a little bit messy because like it's not super easy to get rid of the z's on this. Like I'm going to have to multiply both of my equations because there's nothing I can multiply, for example, 2z to make it the opposite of 3z or vice versa. So one easy way to handle this, though, is we can multiply by each other, basically. Like to make the top the opposite of the bottom, I can multiply it by -3. To make the bottom equation the opposite, I can multiply by 2. I want to do one of them negative, one of them positive, so because I want to switch the signs because right now they're both positives. But if I do this, my new top equation would be -3x plus 6y minus 6z equals -27. My new bottom equation would be, since I'm multiplying by 2, it would be 4x minus 10y minus 6z, or sorry, plus 6z equals 32. So if I do my elimination, my z's are going to cancel, which is what I wanted. And I would end up with 1x minus 4y equals 5. I am writing way too big. We'll see if I can make this work. I might have to kind of just right below. But this is our equation we got. So now using this equation here that we just solved for in this original equation up here, now we've got two equations that just have two variables. We can use elimination or we could use substitution to try and solve for either our x or y. So we're basically kind of like, if you looked at the steps like on our notes, we're kind of skipping step 2 because we already have this equation in the original up here. So we're kind of going to like, it would be step 3 technically, but I'll just call it our second step. We're going to use these equations we have. So I'll call this step 2 because it technically is our second step in this problem. But so we're just going to copy the equation 2 from the original. So -x plus 3y equals -4. And then our bottom equation here would be 1x minus 4y equals 5. So the x is already kind of set up to eliminate. So we might as well just get rid of the x's. So we would have -1y equals 1. So our y would be -1. You can plug this y back into either the equation we got here or the second equation from the original. Basically, we want to plug it into one of the equations with just two variables, because then we can solve for our x. So I'm just going to plug it into the one here, but it really doesn't matter. You could plug it into equation 2 in the original. You'll get the same answer, but we would have 1x minus 4 times -1. That would really turn into a plus 4. So if I solve this, I would get x equals 1. So now that we've got two of our variables, I can plug them into either of these original equations. Like you'd want to plug it into equation 1 or equation 3 because it's got all 3 variables, because we're going to solve for our z now. So if I do this, I'll just do the top one. Well, I would have 1 minus 2y. That would really turn into a plus 2, because -2 times -1. And then plus 2z equals 9. So I'd have 3 plus 2z equals 9. So if I solve that, I'd have 2z equals 6. And if I divide that, I would get z is 3. So I know this is kind of all over the place. And I know, but our final answer for this would be 1, -1, and 3, like our x, y, and z. I'm going to pause the video, but I paused it during that. Let's look at example 5. Okay, so this one's not going to really have any weird things. So this one we're actually going to do all of these steps, basically. There's not going to be like any, like we were kind of able to skip a step in this example 4, if that, I don't know if that makes sense, but for example 5, the first thing, like I said, let me try not to write like a child. But these are like, I number these equations. We have equations 1, 2, and 3. So our first step is you're going to pick any of the 2 equations and you're going to eliminate one of the variables. So like, for example, you could do equations 1 and 2, you could do equations 1 and 3, or you could do equations 2 and 3. I mean, you really have 3 options, if that makes sense. So, I mean, I'm not seeing anything that looks super nice. Like, I don't see anything that looks like it's going to eliminate like right away. Usually if you see something that looks good, you might want to pick that parent. But sometimes it doesn't really matter, because then when you have to do it for your second set, it might not be super nice anyways. But I'm just going to do equations 1 and 2. So the first thing I'm going to do is just copy those equations, like those original equations. So then equation 2 is 2x minus y plus 3z equals 4. Anyone have a preference which variable we get rid of? Just keep in mind, whatever variable we decide to get rid of here, we're going to have to get rid of next. So sometimes even if it looks easy for this one, it might make your life harder the next one. But I'm seeing a lot of people say y, which definitely is the nicest one for this parent. We'll see how that looks for us later. So I'm going to do, you definitely want to do elimination, at least, especially when you have 3 variables. I mean, it is possible to do substitution, but I honestly, if you want to do it and you figure out how it works, go for it. But I don't know. I've never been a huge fan of substitution, but we can multiply this bottom equation by 2, because what that will do, that'll make our y's opposites of each other. So just make sure you multiply every piece by 2. So you don't have to do this, but like we're pretty much ignoring this now. So I don't know if it's helpful to cross it out or not, but we're going to add together the top and our new equation together. So we would have 7x, our y's cancel, which was our goal, plus 10z equals 11 plus 8, that would be 19. Okay, so we've got our first equation with just 2 variables. So for step 2, we're going to pick 2 different equations. Like we can't do 1 and 2. We have to either do 1 and 3, or we have to do 2 and 3. And since we got rid of the y's here, I have to get rid of the y's in whatever parent I pick. So I'm looking at my equations right now. I'm looking at 1 and 3. I want to look at those y's. So I have 2y and -3y. Not super nice. I'm going to have to multiply both equations for elimination, if that makes sense. But look at 2 and 3 together. 2 and 3, I have -y and -3y. So like I could get rid of the y's with just one multiplication. I don't know if that makes sense, but 2 and 3 looks like the easier pair to me. Like it'll make my elimination process easier. But you need to make sure you pick 2 different equations, but you might want to kind of look at them both and see which one looks like it'll be easier to do what you need to get done. But 2 and 3, I agree with In the chat, that looks a little bit easier. A couple people said that. So I'm going to copy equation 2 and equation 3. Remember, since I got rid of the y's for my first parent, I have to get rid of the y's in this parent. So to do that, I could multiply this top equation by -3, because that would make this a positive 3y. It would make it the opposite. So I'm going to write it below. So this would be -6x plus 3y minus 9z equals -20. No, -20, -12, sorry. Like I saw it right in my head, but I said it wrong. Let me just clean this up. So -12. So I'm just going to like cross this out. We're not looking at that one anymore, but we're going to add or use elimination between these. So we would have -1x. Our y's cancel, which is what we wanted. And we have 5 minus 9, or 5 plus -9 would be -4c. And then -1 plus -12 would be -13. So what we just did in steps 1 and 2 is basically we created two equations that just have the x and the z variable. So why we did this is now I can put these two equations together and I can eliminate either the x's or the z's. So I'll be able to get one of my answers basically. That's like what steps 1 and 2 were kind of guiding us towards. So let me see how I'm doing in terms of space. So for step 3, and I don't know what you want to call these, but if you call these like equations A and B, or vice versa, maybe I'll call this first one A, the second one B, but we're going to put these two equations together. So like I'm just going to copy what I had. So I had 7x plus 10z equals 19. And I had -1x minus 4z equals -13. So it's up to us, honestly. Well, the x's look a little bit easier to get rid of here, but you could get rid of the z's if you want, but you're going to have to, like, to get rid of the z's, you'd have to multiply the top equation and the bottom equation, so it's a little bit more work. But the x's, you could just multiply the bottom by 7. So I'm just going to write my new one. So that would be -7x minus 28z, 7 times -13, that would be -70, -91. So I'm just gonna, I like to kind of just cross that out. So I know I'm just looking at the top and bottom. So my x's cancel. My z's, I'd have -18z. 19 plus -91, what would that be? That would be 72, -72. So then if you divide by -18, well, 1836, so it would be 4. And let me just double check my key because I was doing all that in my head. Yeah, that's what I got on my key. So I don't think I messed up my mental math. So we've got one of our answers. Hooray, hooray, we're 1/3 of the way there. We're actually closer than that, I mean, but in terms of our answer, 1/3 of the way there. So you can take this result and you can plug it into either here or here. So if one of them looks easier for some reason, I guess you could pick that. I mean, usually probably not going to matter too much. I don't know. I'm just going to plug it into this guy here because it's closer. But I mean, maybe equation A might be nicer. You don't have any negatives, if that matters to you. But this would be -1x. If I plug in 4 for my z, that would be -16. So if I solve this really quick, I would add the 16 over. I would get +3. Divide that -1, I would get -3. Hooray, we're 2/3 of the way done. Almost there. So to get our final answer, we need to figure out our y. You can take these two answers we have, and you can plug it into any of these original equations. So if one of them tickles your fancy for some reason or looks easier, pick which one you think looks the easiest. But usually, I mean, it's not going to matter too much. I mean, It shouldn't be really too bad for any of them. So where am I going to put this work? I'm just going to plug it into the first equation because I'm not very original and I don't want to think. So I'm just going to pick the top one. So I'm going to plug in -3 for x. And I don't know my y. And I'm going to plug in 4 for my z. And I just want to see what my y will equal. So I'll have -9 plus 2y plus 16 equals 11. So if I combine those together, that would be 7. And sorry, this is like if I combine the 16 and that -9, that would be 7. If I subtract, I would get 4. If I divide, I would get 2. But if you work that out, or if you picked a different equation, you should still get this answer. So our final answer would be our x, -3, comma our y, 2, and comma our z, 4. This question here is as bad as it can get. We weren't able to skip any of our steps because they didn't give us any equations with just 2 variables. So we had to create them in steps 1 and 2. And then once we got them in step 3, we could eliminate to get one of our variables, plug it in to get your y or one of your other variables, and we plug it in then to with our 2 answers into one of the originals to get our final solution. This is the process. I don't know. I'm a math guy, I guess. I kind of like this because it's a big process. You feel like, I don't know. I feel like I really get somewhere when I do one of these questions. I don't know. Maybe it just seems like, what the hell did I just do for the past 10 minutes for some of you? But I don't know. I kind of enjoy this, but I know I'm a weird person. So, any questions about this second example we've done? All right, so I had you guys try this one in class, but I'm going to work it out just in case you want to see it in the video. So like I said, we have equations